Hello, everyone. In this unit, we're going to be talking about the graphics module, also known as the graphics library. You'll hear it called both. It means the exact same thing. It is a Python program, a library that you can import into your programs, and it allows you to create two-dimensional or 2D interactive graphic programs. We're going to be doing that from this point forward, from Unit 2, 3 through the end of the semester. And in fact, it's a big part of Milestone 2, 3, and 4 as we bring together our overall program that you're going to be writing as your project this semester. So as we work with this library today, I'm going to give you a bunch of examples. We'll review some examples. We'll talk about all the elements that go into the graphics library. So why don't we go ahead and get started. So the graphics library, as I said, also known as the graphics module, interchangeable names. The graphics library is a tool we use that can allow us to create shapes. So you want to create a circle, you have to know how you create that circle. Where's its center point, its XY coordinate, what's its radius, what's its fill color or its outline color, those kind of properties. Or maybe you're creating a rectangle or a line. And you want to think about what you need in order to create each of those shapes. For example, a rectangle, you just need a corner point, and then it can define a rectangle. So we're going to talk about the graphics library and all the elements included in the graphics library. We'll talk about the different graphic object types, the shapes, the text, the other interactive elements that we can use, the way we can interact with the mouse with the graphics library. We're going to talk about how to create them, but also how to set and retrieve their properties. So if you set the radius of a circle to be 10, how can you later check what the radius of that circle is? Or maybe you create 10 circles with random radius, and then you later on want to determine what their radius is. So you can set them and get their properties. We're actually going to talk also in this unit about working with objects and setting and retrieving their properties. And it's something we've been doing with lists and strings this semester, but we'll talk more about that. There are a bunch of examples posted in Unit 2, 3 on Brightspace, and we'll talk about at least two of those today, the bouncing ball program and the bubbles program, and we'll look at those as examples, as well as a few others. There's some more examples printed in the course handbook, and we'll take a look at those as well. So the graphics library is designed to simplify object-oriented programming. If you remember, this course is entitled Programming with Multimedia Objects. Multimedia objects, right? Those are any kind of a programming object. We're going to talk about what objects mean, but any kind of programming object that allows us to produce multimedia output. So it's not just all about text and strings. It's also things like data files. We'll get to those next module. But it's also about objects. And the nice thing about working with the graphics library is when you create an object, you can see it. And if you modify that object, if you move it or change its color or click on it with your mouse, then you can interact with it, and it's a multimedia element. So we can create things with the graphics library like a point. It's not a dot, it's literally a center point, like this X and Y coordinate is a point. A line that's defined actually from one point to another, one XY coordinate to a second XY coordinate. A fill color, like it's literally, we just use colors like red, blue, green, gold, yellow, and pink. And movement, we can interact with those objects, but we can also change their position on the screen, and we move them around in XY increments. So you don't say move to X coordinate 100, Y coordinate 100. Instead, you say move 10 pixels in the X direction and maybe minus 5 pixels in the Y direction. So we incrementally move these objects around on the screen. And any sort of text and other element, even graphic files, you're going to work with those in Milestone 2, like GIFs or JPEGs, that sort of thing. You can display those as well as text and manipulate and move them around. So we want to get very familiar with the graphic object types so that we know how to work with them. The graphics documentation, in fact, is all of Chapter 4 in your textbook. So open up your textbook, go straight to Chapter 4, review that chapter more than once, because that is going to be your reference point as you're working with graphic objects this semester. So as you're given an assignment to create a circle at a certain location or to create a graphics window of a certain size, chapter 4 of your textbook. If you want a quick reference, there's a PDF file. This is also linked on Brightspace, so you can go find it. There's a PDF file that gives you sort of a shortened version, a quick reference without so many examples, but the textbook really is your main reference point, and you want to use that maybe and supplement with the PDF file. Then there is the library itself, graphics.py. Notice the lowercase g, graphics, not uppercase G. It's a py file. It's a Python file. You can open it and read it. And in fact, there's even more documentation inside the .py file, the graphics.py file. Take a few minutes, review it. You might see something in there that later on you think into yourself, how do I do this task? And then you remember, hey, that's in the documentation. I remember seeing it there. I can go look it up again, and I can use that portion of the graphics library to make this change or make this decision or manipulate the graphic objects in some way. But the graphics.py file is also something you must download. It's in Unit 2.3 under the graphics library examples, and you save it in the same folder as your Python program. So if you're going to create your lab assignment for Lab 2.3 and you create a folder for it, so you're going to store your lab assignment in that folder, also store a copy of graphics.py in that folder. You're going to need it in order to be able to import it and use it in your program. All right, so we've got to have graphics.py. The documentation is super helpful. Read chapter 4 of the Zell textbook and review the PDF file. Okay, so the simplest graphic objects to create are points, circles, and rectangles. And you're going to create these things over and over and over again. A point object just needs an x and y coordinate. So I want to create a point object at x of 10, y of 100, or x of 250, y of 250, whatever they are. So you just say P, that's the name of the object. Just like when I create a new list, I'll say like my list equals capital L list, and then we have the definition of the list, like a left-right parenthesis, or I could use the square brackets for a list. When I create a point object, I'll say P, that's going to be the name of my point object, equals a point, capital P point, at these coordinates. A circle object needs a center point and a radius. So if I've already created a point named P, I can use that definition here to create my circle. Or in here, I could say add a point, XY coordinate. That's another way to do it. So C equals a circle at point P, because I've defined it here, with a given radius, like 10 or 12 or 15 and a half or whatever. And then C2, a different circle, is a circle at this point and this radius. And you could use variables here for the XY coordinates and the radius if you want to, if you have float or integer variables that you want to use. And that's how we can create the circle with a single step. We don't have to define a point first and then the circle. You could do it all at once like this. A rectangle needs two opposite points, the corners, right? So if I have a corner here and a corner here, that then defines the borders of my rectangle. So I just need these two center points. So R equals my rectangle, notice it's a capital R, at point XY, second point XY. So these are the two corner points of the rectangle. I strongly encourage you when you create rectangles to always define them as upper left corner, lower right corner. The reason why I recommend that will become more clear later in the semester, but if you stick to that standard, upper left corner, lower right corner, it's going to make some of your programming tasks later on a little bit simpler if you always know where those corner points are. So setting and getting or retrieving object properties is pretty simple. Let's say I have a line that's C equals a circle at point 20, 20 with a radius of 10. And then I draw that circle in my window, my graphics window. Then I can change its fill color to blue. Then I might move it. Now notice this dot reference. This should look familiar. Something we've done with lists, like list.append, or string.lower, string.upper. So these objects, like this circle, have properties. We can draw it, We can change its fill color. We can move it, and this would move it 10 on the x-axis and 15 on the y. We can then retrieve a center point, which is the center of the circle. Now, remember, I drew it at center point 2020, then I moved it. So what's its center point now? Quick little math, 20 plus 10, I should get 30. 20 plus 15, I should get 35. So this get center gets a point object with the x and y coordinates of the center of my circle. Then x equals p dot get x, y equals p dot get y. I'm retrieving the x and y coordinate from the center point of the circle. So I can now determine where that circle is. What if that circle's moving around the window and it's moving around the window and I want to know if it's too close to the edge or too close to the top or too close to the bottom? I could retrieve its center point and determine that. We'll look at some examples of that a little bit later. So we can set and we can get properties of an object, and all of these methods, these functions for setting and getting for circles and rectangles and points and all of that, this is all documented in chapter 4 of Zell. Make sure you take the time to review that, and also the PDF file, which is the documentation. So let's take a look here at a Python program that uses the graphics library, and let's describe what's actually happening. Now, first thing we have to do, if we're going to use the graphics library, is we must import it from graphics import star. So the graphics.py file must be stored in the same folder as my program. So if this program was called what's happening.py, whatever folder the what's happening.py file is stored in, the graphics.py file must also be stored there. Okay, so this from graphics import star, it's going to look for graphics.py. Notice the lowercase g here. The file name has a lowercase g. That's relevant. Make sure I didn't put .py here. You don't do that. It assumes that. So from graphics import star. That's the first line. So now I've added basically to my program everything that's in the graphics library. The ability to do things like create a circle, draw it, change its fill color, create points, like this part here, create rectangles, etc. That gets added to my program without all that code being in my program. I don't have to read it. So then I define my main function, and the first object I create is called win. A graph win is a graphics window. All your graphics belong in a window. So you create a graphics window, it will appear. It then has a name, a title in the title bar, and a dimension in pixels. But in this case, I've chose 300 by 300. So I'm creating a 300 by 300 graphics window. Think of it like a palette. You're creating a palette in your window, and you're going to draw all your graphics in that palette. In this case, I've created a 300 by 300 pixel palette, and everything that I draw is going to be inside this palette. I've named this palette Win. So that way I can tell Python where to draw the graphics. So Win is going to be my graphics window. Its title bar is going to be Win, W-I-N as well. This is just a readable text, by the way. It doesn't matter what this says. You can have it say pretty much anything. And then here's my X and Y coordinates for the size of the window. I create a point object named P. So a point object at 50/50 is named P. I create a circle object. Its center point is P, a radius of 10. Now, does it appear on the screen yet? No. Because I've just created the object, I haven't told Python where I want to draw it. That's the next line. Here's my object definition. C equals create a circle at center point P of radius 10. Now C dot draw. Remember I created the circle here. Draw it, and where do I draw it? Well, I'm telling it Win. That's because I've named the graphics window Win. So if you kind of take a look at this, I'm going to draw a circle in graphics Win. The circle has a center point at 50/50 and a radius of 10. These lines together are all required just to see the circle. I've created a graphics window for the circle, I've created a center point for the circle, and I've created the circle itself, and then I drew it. Then I changed its properties. I set its fill color to blue. So it's a blue circle. And I'm going to have a for loop. I'm going to loop from 10 to 15. So dx is going to start off as 10. I haven't specified an increment, so actually it's going to be 10, 11, 12, 13, and 14, right? So I'm going to have 5 values, 10, 11, 12, 13, and 14, each time the loop repeats. I'm also going to go through a list of colors for color in red, blue, green. This is using a for loop to increment through a sequence in a list. So the variable named color is going to start off as red, and then it'll be blue the next time the loop repeats, then it'll be green. dy equals dx plus 2. So I'm creating this other variable, dy, it's whatever dx was, starts as 10, plus 2. Move the circle by dx dy. dx started as 10, dy was 12. So it moved the circle 10 by 12. It changed its fill color to whatever the next fill color is. It got the center of the mouse, and then, our center of the circle, excuse me, and then this command, getMouse, says wait for a mouse click in this window. What is this window? When? Oh, I've defined it here. That's the window where the circle is drawn. So basically what's going to happen is I'm going to click in the graphics window, and it's going to move the circle and change its fill color. How many times? Well, this for loop repeats 10, 11, 12, 13, and 14. It repeats 5 times. And inside this one, we would go through these three colors. So 5 times 3 is 15. So this is going to 15 times wait for a mouse click. And every time there is a mouse click, it's going to change the fill color and move the circle, and eventually start moving it more and more and more. So it'll start moving it a little bit, and by the end it's moving it a lot, and it is moving it and changing its color at the same time. And then when all of these loops are done, the graphics window gets closed. I create the graphics window, I create a circle, I draw it, I move it and change its color 15 times, and then when I'm all done with those, I close the graphics window. So the very last command of my program here is, yes, I've defined main. I call the main function. So Python reads from graphics import star. It extends my program by all the stuff that's in the graphics.py file. I define the main function. I call the main function, and all of these things happen. So what's happening, right? A graphics window appears, a circle gets drawn of a certain color, and every time I click the mouse, the circle moves a little bit and changes colors. 15 times it does that. That's great. That's great. It's interacting with me. It's waiting on a mouse click. It's drawn a circle. The circle is moving. Its fill color is changing. This program is saved on Brightspace in the graphic programming examples. Load it and run it and see what happens. See that it actually does interact with you 15 times, changing the circle's fill color and moving it, and then it just closes the graphics window when it's done. So there's a lot of things going on here. For a pretty simple, small program that just interacts with the user a few times and then closes. So import the graphics library. This is important. Create a graphics window of size 300 by 300. Create a point object. Create a circle object with radius 10 centered at point P. Draw the circle and change the circle's fill color to blue. By default, by the way, the circle's fill color is white and its outline color is black, and you can change all of those things. You can set the fill color to black, you can set it obviously to blue, red, green, and we just use regular words in quotes for the fill colors. This section here where it's doing the movement, this nested for loop moves the circle diagonally and waiting for a mouse click anywhere in the window before changing the color of the circle and moving it again. And then it will eventually move it 15 times and change its color. How about this program? This one's printed in your handbook, and it's called gridtest.py. The definition of it says that it creates several circles and waits for the mouse click, and each circle changes color on a click, and then a final click ends the program and closes the window. Let's go through it real quick. From graphics, import star. Well, there's my import of the graphics library. here is the random library. We can randomly choose a value from a sequence, like a list, a string, whatever kind of sequence we have. With this choice command, we just import that from random. This is much like importing things from the math library, right? From math, import cosine. From math, import, whatever it is that you need to import, pi. So we can import choice from the random library. Now I've got two functions here. One makes a grid. The grid has a graphics window in it. I create a list for my circles. I'm going to loop from 20 to 140 by 40 increments and create a circle at each of these locations and radius. So whatever I is, starts off as 20, it creates a circle at 2020 with a radius of 20. Right? And the next time it's going to create it at 6060 with a radius of 60, etc. The title of the graphics window is hello there, by the way. Notice I didn't give it a size. If you don't specify a size, it assumes 200 by 200, by the way. That's in the documentation. I'm going to set that fill color to red. I'm going to draw it in the window, and I'm going to append this circle to my list of circles. So I created a list called circles, and I'm going to append all these circle objects in it. There's a reason for that. We'll see that in a minute. And then we're going to return both the graphics window and the circles. This is one of the key things you need to keep in mind when you're working with graphic objects. If you have a function that creates a bunch of objects and you want to be able to interact with them later, like your graphics window, or in this case, my list of circle objects, you must return them from the function. It's something we learned, right? What happens in the function stays in the function, right? By returning these objects, the graphics window and my list of circles, I can then work with them in another function as well. So here's my main function. I've got a list of colors, pink, green, blue, and gray. I'm going to say this object called grid and this object called circles equals, call the make grid function. What did the make grid function do again? It created the graphics window and the list of circles and returned them. This is weird though, because in the make grid function, I called it win, and here I'm calling it grid. Is this okay? Absolutely. In the main function, there's a variable called grid, which is the graphics window. It doesn't matter what I called it up here. I'm going to call it grid in my main function. The circles list is called circles. So then grid.getMouse. GetMouse waits until there's a mouse click for each circle in circles. I love writing Python that's readable. You should be able to read it almost like a set of directions. So if I say for each circle in a list of circles, that tells you what I want, right? If I had a stack of paper and I said for each piece of paper in the stack of paper, do this, you would know that you're supposed to grab each piece of paper, do something with it, set it aside, get the next one. This for loop says for circle in circles, and it's the same concept. I can read this almost in natural English for each circle in the list of circles. I know it's a list because I created it as a list in here, and I returned that list, and I stored it here. So for each circle in the list of circles, set its fill color as a random choice from this list here. Then get mouse. Again, wait for a mouse click. Then close the graphics window. So basically, as I click in the graphics window, each of the circles, and how many circles will there be? There's one at 2020, 60, 60, 100, 100, and 140, 140. So apparently there's 4 of them, right? That's my for loop here. The first one was at 2020, then I added 40 to that, 60, 60, add 40 more, 100, 100, add 40 more, 140, 140. Not going to go past that because the ending number is 141. So I have 4 circles, and that's the list of circles we're going through here. So basically 4 times I'm going to click the mouse, and each of the circles will take a turn of having their color changed to a random color from this list of colors, choice from colors. When it's all done, when this loop is over, I close grid. What is grid? Grid was my graphics window I created, and my program's over. So what does this program do? Creates a graphics window and 4 circles at points 20, 20, 60, 60, 100, 100, and 140, 140. and they are all red. And as I click in the window, each one changes colors randomly between pink, green, blue, and gray. And then after each one has changed colors, the window closes. All right, let's look at this one. This is a utility function. You're going to want to add this kind of function to every single program you write that interacts with the user. If you're wanting to know whether the user clicked inside of a circle or outside the circle, or inside a rectangle or outside a rectangle, think of that rectangle maybe like a button, right? You want to know if the user clicked inside the button or outside the button. Because if they click inside the button, you're supposed to do something. This function is clicked R, accepts a mouse point, that's the center point where a mouse click was, and a rectangle object. And the first thing it does is check to see if there really was a mouse click. If there wasn't, it just says, nope, this rectangle has not been clicked. Then it gets the X and Y coordinates of the mouse click, get X and get Y. If you recall earlier, I showed you that get X and get Y are how you retrieve the X and Y coordinates of a point object. A mouse click is a point object. Then get the X and Y coordinates of the corners of the rectangle. So X1 is rectangle dot get its first point and get the X from that. And then get the first point and get the Y. Store those in X1 and Y1. This is an example of simultaneous assignment that we talked about probably the very first week of the semester. Remember this, like X comma Y equals Y comma X, simultaneous assignment. In this case, we're saying assign the X value from the first point of the rectangle, the upper left corner, to X1, and the Y coordinate of that same point to Y1. Do the same thing for X2 and Y2. Now, I have these two corner points, and I have a mouse click. If the mouse click is in the middle of the rectangle, then the X is going to be in between these two X's, and the Y will be in between these two Y's, right? So that's what I've done here. Return, and here's my Boolean statement. Remember we talked about Booleans, and we talked about building these Boolean equations that resolve as true or false. In this case, I've built an equation that if the X coordinate of the mouse is in between the X coordinate of the 2 points, and the Y coordinate of the mouse is in between the Y coordinates of the 2 points, both of those things must be true, then this will return true. If either of these is false, this will return false. So I'm using my Boolean equation skills here to produce a true or false output based on whether a mouse click is inside of a rectangle. So this function does nothing but return either true or false. That's all it does. It returns true or false. The mouse click was inside the rectangle or it was not. Here's an example of the same concept, but in this case is the mouse click inside the radius of a circle? Is it within a circle? So all the same concepts, if there really wasn't a mouse click, just say false. It's not inside the circle, there wasn't a mouse click. Then we get the X and Y coordinates of the mouse click, we did this already. And then we can get the XY coordinate of the center of the circle. So CX and CY is get X from the center and get Y from the center. Center is the center of the circle. And what is this? This looks like this big complicated equation. Break it down for a minute. This is an exponent with a fraction. It's 1/2, so that's the square root. The square root of all of this stuff, the middle of the mouse click minus the X coordinate of the mouse click minus the X coordinate of the circle squared, plus the Y coordinate of the mouse click minus the Y coordinate of the circle squared. This looks like A squared plus B squared, the square root of that. What am I checking here? Well, I have 2 points, a mouse click and the center of a circle. I'm measuring the distance between them, aren't I? This is just Pythagorean's theorem. So the distance between the mouse click point and the center of the circle should be less than the radius of the circle if the click was inside the circle, which is what this says. Returns true if the click is within the circle, otherwise false. return, and here's a Boolean equation for us. Distance, that's my calculated distance, is less than or equal to get the radius of the circle, right? So is the distance, Pythagorean's theorem, less than or equal to the radius of the circle? If it is, then that mouse click was inside the circle. True. If it's not less than the radius of the circle, then false. The mouse click was not inside the circle. This function, and the first time somebody reviews it with you like today, it may not like really connect with you how you would use it. But this function and this function are functions you're going to use this semester. I'm giving them to you so you can see them as examples of how to use Boolean equations, graphic objects, how to set and get their properties. But also I'm giving them to you because these are how you're going to write interactive programs this semester. Use them. It'd be like if you went and took a job as a carpenter and the first day your boss handed you a hammer and a pair of pliers. Put those tools in your pocket. You're going to use them again. You want to hang on to those. All right, on Brightspace are some programs, example programs, a bunch of them. One of them is called Bouncing Ball. Let's take a look at Bouncing Ball. And I'm going to jump over here very quickly to Bouncing Ball. Where is it? All right, let's take a look at Bouncing Ball. This is Bouncing Ball, and it's loaded on Brightspace already. And what you're going to do is, in this case, this program's job is to create a little circle that animates around the window. Now, I'm not going to go through it line by line. It's fully documented for you, but I'm just going to run it for you. And when I run this program, here's what I get. A blue circle that moves, and when it approaches the corner or the edge of a window, it changes direction. This is all of this program. The main function creates a graphics window in a circle and changes its fill color and stuff. And then this while loop is just going to keep looping until I click in the window. So while not win.checkMouse, as long as I have not clicked in the window, then move the ball, pause for a second, and then get its dx and dy coordinate. This is where we're checking to see if it bounces off the wall, and then move it again. Notice I'm moving it by dx and dy, so we're going to update dx and dy. This is the direction of movement in x and the direction of movement in y, dx, dy. So it just keeps doing this until somebody clicks in the window. So when I click in the window, it says all done. Here I've created a text object at the center of this window that's all done. There it is. And then I'm waiting for another mouse click. By the way, you'll note this program uses get mouse here that stops the whole program and waits. And up here, I'm using check mouse, which does not stop the program. It just looks to see if there was a mouse click and then moves on. So right now I'm down here at get mouse. I've already printed my all done. When I click again, it's going to close my window, and that's the end of the program. And it's done. So let's run that one more time. Here it is, bouncing around the window, bounce, bounce, bounce. And it'll do this for infinity, as long as my computer has power. Click, it says all done. Click, it closes the window. Well, let's take a look at this other one, which is called Bubbles. Bubbles is a little more complicated. It's a little bit longer, but to be honest with you, it looks a lot longer because I have these great big comment blocks. But I wanted to describe what's happening in the program so that you can see it working, okay? So I'm gonna run it. And it draws this graphics window, 400 by 400 pixels. And then there's some instructions in here. Click on a bubble to push it. So if I click this bubble, it moves it. And it slows down until it stops moving. If I click this bubble, it moves it. It's moving it in a random direction. That's why I have this random integer here. What happens if I click where more than one bubble is? Well, they all move, don't they? Because it detected my click inside all three of those bubbles, it moved them all. How about this? Yeah, got them both to move that time too. Move this one. It only accepts a certain number of clicks. Eventually, it's going to tell me that's enough clicks. You can't click anymore. By the way, you'll notice these are going to all move at the same time. 10 clicks is enough. It says click somewhere in the window to end, and we'll end it. Let's run it one more time. Let's see how many bubbles I can get moving at the same time. Boom, 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 boom. Oh, 10 clicks is enough. Yeah, it only goes for 10. You could change that, by the way. It's probably a for loop somewhere in here that only goes to 10. Oh, it's a while loop. While clicks is less than 10. So if I want to do 20, I can change this number to 20 if I wanted to, or 5 or 2 or whatever it is that you want. So it's just picking a direction, a dx and dy, and moving it in that direction. Okay? So this is the bubbles function, bubbles program. So take a look at those and see what you think and see what you can learn from. Great. There's a lot to learn with the graphics module. You definitely need to read chapter 4. You just have to. And go through the graphics module documentation, that PDF that I linked for you, and spend some time looking at the examples I've provided. They're going to teach you so much. And then as you got your assignments coming up for programming exercise 2.3 and lab 2.3, they're very heavy into using the graphics library. In milestone 2, you're going to be creating a full program using the graphics library, and it's going to be your Trinco Gold game board. So we've looked at creating the quiz in milestone 1. In milestone 2, we're going to be creating the graphics game board that goes along with your program. So take the quiz that goes with this lecture and then go on and move on to the next unit. Have a great day.